That's weird.
I don't use it that much.
Well, maybe your battery's starting to go. Hi, everybody. How are you guys doing?
Tired.
Tired. Layla and Paulie, can you guys work on your outerwear situations for me? Thank you. Appreciate it. Second, you all right?
Yeah.
Okay. So let's start with questions from homeworks. At this point, I've asked you guys to do worksheets 1 and 2. We've talked about those a fair bit, but if there's still some more on that you want to talk about, happy to do that. And then I'd ask you guys to work on like 1 through 16 as your asynchronous assignment from the book. That's not due until Sunday, but if you have questions from that you've looked at, I'd be happy to take a couple of those. Jake?
I didn't see the homework thing, so I left it home back.
Send me an email. I haven't checked anything yet because I was otherwise occupied here this morning, so send me an email, let me know. But I might not get to checking anything till tomorrow. Sometimes that just happens. And if it's there when I check, that's fine. You know. So am I correct in understanding that no one has a question from homeworks yet? Okay, Ava.
Can we do number 2?
Number 2. Sure. Okay. So 2 asks us to find the exact value. So because we're using tan inverse, we want to remember the range for tan inverse is negative pi over 2 to positive pi over 2, i.e. quadrants 1 and 2. I'm sorry, 1 and 4. Hi, Alexis. How are you?
Good.
It's great.
Thanks.
Reese Hale. Get out of jail free card for Reese. You're welcome. Exciting day. So I'm then going to remember that tangent is y over x. So I'm going to be looking on the unit circle for where y over x is equal to 1, because we're doing tan inverse of 1. That's the same thing as saying where x and y are the same. So far, so good, Ava? So let me grab my unit circle and drop that in here so we can look at it while we're doing this. So if I look in quadrants 1 and 2, or 1 and 4, excuse me, the only place where I see the x and y's are the same is here. So my answer should be pi over 4. And I'm done. Does that feel okay? You're back. I thought your name was Mary. Shoot, have I been calling you the wrong name all year? Back. Ha ha ha! Other questions? Go ahead, Ava. Okay. So there we have arctan of negative 1/2. Oh, did we mention the difference between arctan and tan inverse? Or arc cosine and cosine inverse? Guess what the difference is?
There's
Nothing. They mean the same thing. That's probably why I forgot to mention anything. All right. So I remember that the range for arc cosine is 0 to pi. That means I'm looking in quadrants 1 and 2. And cosine is x. So I'm looking for in quadrants 1 or 2, where the x-coordinate is positive 1/2. So let's see, that happens here at pi over 3. Ava. Good? It's kind of like worksheet 1 stuff still, right? Just instead of giving you a specific interval, you're using like the ranges for the functions. But it's still essentially the same problem. So if you felt good on worksheet 1, that set of problems should still feel pretty good. You just had to remember what the ranges were for sine, cosine, and tangent inverses. All right. Should we continue on? Cool. Just pull this up. I forgot where we left off at. I have to check real quick to pull up my notes and see where I was at. Blah, 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 blah. Okay, yeah, we should do some of those. Okay. So a little bit more in 4.1. Look at a couple of different types of problems today. So nothing new conceptually, we're just looking at new problems to do. So on a problem like this, we're going to start with the inside. So I want to start by figuring out what tangent of 45 degrees is. So to do that, I'm going to go to my unit circle. I'm going to locate 45 degrees. And then I remember on the unit circle, how do I find tangent? Y over x. So my y is root 2 over 2, and my x is root 2 over 2. So this will be cosine inverse of root 2 over 2 divided by root 2 over 2. And what is root 2 over 2 divided by root 2 over 2 reduced to? It's a lot of 2's in that sentence. That fraction, root 2 over 2, over root 2 over 2, how does that reduce? 1. Everybody's happy? Now it's just like one of the problems we've done. So I'm going to go say, okay, well, I know the range for cosine inverse is 0 to pi. So it's like quadrants 1 and 2. And I remember that cosine is x. So I'm going to go look in quadrants 1 and 2 for a place where cosine is, or the x coordinate is equal to positive 1. So let's go back up here to my picture. That's the only place I see where we're equal to positive 1. So my answer should be 0 degrees. How do I know I shouldn't give an answer in degrees this time instead of radians? What was the original question? Was cosine inverse of 45 degrees? Oh, so it should be in degrees because it's like the problem was in degrees. That's all. No good reason. Let's do another. Yay? But again, not too nothing too sneaky here. Now remember, what did we say about these arc functions? They're the same as the inverse things, right? So arc tangent is just the same thing as tan inverse. So no big deal. I'm going to start this the same way. So I'm going to go and find 2 pi over 3 on my unit circle. And remember that tangent is y over x. Oops, I went too far, I think.
What's going in saying arc then?
It's just an older notation. So 2 pi over 3. So y is root 3 over 2, and x is negative 1/2. It just means the same thing as inverse. They're just, like you have a bunch of words that kind of are different words, but they mean the same thing. Same kind of thing here. So y was root 3 over 2. Come on now. You just want to be a... There we go. And x was negative 1/2. Everybody's okay here with what I did? Now remember, tangent is y over x, so I'm not going to reduce here. Oh, before I do this though, what should we probably say first? Should probably remind ourselves what the range for arctangent is. Forgot to say that. Is everybody okay with what I've done here so far? So what I'm going to be doing is I'm going to be looking in quadrants 1 and 2 or 1 and 4 for a place where x is 1/2 and y is negative root 3 over 2, or a place where x is negative 1/2 and y is positive root 3 over 2. Well, I know already which one it is. It's got to be this one. How do I know that? In quadrants 1 and 4, the x is positive. So I'm not going to be able to find a place in quadrants 1 or 4 where the x is negative. So that's where I'm looking. So we're right here at 5 pi over 3. But uh-oh, I got a little problem with that. What's my little problem? What's the range for this function? Negative pi over 2 to positive pi over 2. Is 5 pi over 3 in between those two?
I don't know the ranges.
We had those earlier. These are just things we've memorized. So like sine inverse the range is negative pi over 2 to positive pi over 2 with brackets. Cosine inverse, the range is 0 to pi with brackets. And tan inverse, the range is negative pi over 2 to positive pi over 2, but these are with parentheses. So that was a little sidetrack for remembering what those ranges were. But my question still stands, is positive 5 pi over 3 in between negative pi over 2 and positive pi over 2? Well, of course not. 5 over 3 is like 1 2/3, right? That's way bigger than a half. Everybody agree? What do we do when our answer is too big for our interval? Yeah, it starts with a C. We find a coterminal angle.
Yeah.
And how do we do that? We subtract, in this case, because we're too big, by 360, but since we're in radians, we should really use 2 pi. So to subtract those two numbers, what do I need to have? Common denominator. What would that common denominator be between 5 pi over 3 and 2 over 1? Well, 3. So instead of thinking about that as 2 over 1, I'll think about it as 6 over 3. And I get negative pi over 3, which is definitely between negative a half a pi and positive a half a pi. So far, so good? Okay. I have a new type of example problem. Why don't you just... So here's a new type of problem, similar to what we've been working on before. This says find an algebraic expression equivalent to sine of arc cosine of 2x. When we say algebraic expression, what does that mean? What should our answer look like? Yep, which means what? Not y equals mx plus b. That's a... But it means it's going to have like x's or y's or something in it, right? Yeah. It's not going to just be a number. Okay? Everybody's good with that? Could it still just be a number? Yeah. Yes, but it doesn't have to be just a number. Okay. So here's the trick. We're going to start with the inside. So the inside says arc cosine of 2x. And when I do a cosine, or when I do one of these inverse functions, I know I'm going to get an angle for this, right? Everybody agree with that? that's equivalent to just saying cosine is theta is equal to 2x. If I say theta equals arc cosine of 2x, so what I'm going to do is I'm going to draw a right triangle now that makes this true for this angle theta. So in a right triangle, what is cosine equal to? In a right triangle, what is cosine of theta equal to? Think back to SOHCAHTOA. SOHCAHTOA. Adjacent over hypotenuse. So 2x must be adjacent over hypotenuse. So what's adjacent going to be? 2x. What's hypotenuse going to be? 1. So far, so good. What I need to do now is I need to find this side y in terms of x. So what equation relates the three sides of a right triangle together? The Pythagorean theorem, right? A squared plus b squared equals c squared. So what side has to be c? You could just tell me in our picture, the 1, the hypotenuse, must be c. So a squared plus b squared equals c squared. So far, so good. So what is 2x squared equal to when I simplify that? Well, this is taking too long. What if we think about it as 2x times 2x? 4x squared, right? And y squared would just be y squared. And 1 squared is just 1. And remember, what we're trying to do is get the y by itself. So now I'll subtract 4x squared from both sides. And then we'll square root both sides. So y should be plus or minus the square root of 1 minus 4x squared. Now what is this? What is y representing here? In the context of this problem, what does y mean? What is it representing? The height of a triangle, right? So can we have plus or minus for an answer there? No. What does it have to be? Just plus, because it's a length. Everybody's good with that? So when we're doing these problems, are we ever going to get a negative? No, man. All right. Can I simplify the square root of 1 minus 4x squared anymore? Can I write this as like 1 minus 2x? What do you guys think? No! Why not? That surely looks like something I should be able to do.
It'd be a negative and a positive.
That's not the issue.
What would it be?
No.
Would it be two different things?
this is the issue.
Yeah.
That is never true. You can't break a radical at an addition or subtraction symbol. In your mathematics education, the only operations that you know that distribute across addition and subtraction is multiplication and division. That's it. Square roots don't distribute. Logarithms don't distribute. Trig functions don't distribute. Exponents don't distribute. Radicals don't distribute. Nothing you've seen as of yet in any math class you've taken other than multiplication division distributes. If you take calculus, that'll be the next time you see another operation that distributes.
And what was that mean?
The derivative and then the integral. Yeah, so that's not right. So we're done, right? So I'm going to replace y with square root 1 minus 4x squared. Now, if I go back to my original problem, I'm doing sine of theta, right? Because we just found out that this theta is the theta and that is that angle, theta. So if I'm looking at a right triangle, how do I do sine of theta? Come on, guys. SOHCAHTOA. Opposite over hypotenuse. Relative to our theta in our triangle, which side is the opposite? Or square root 1 minus 4x squared. And what is hypotenuse? 1. So that's our algebraic expression. At this point, you guys should now be able to do worksheet 4. I know, I'm excited about it too. Should we do one more of these from worksheet 4? Let's do it, right? Who has a preference? Should we do the first one? That's got a cosecant in it. That's weird. Oh my goodness, that's so embarrassing. That's The Office? Oh. That's really embarrassing. Yeah, somebody's just had to shake it off here, huh?
Sounds like it's a tunnel.
Well, I just emailed the office to let them know that we can hear their music right now.
Someone hacked this.
Oh my god.
At least Nico's not here today to complain about it, though, right?
I'm so happy.
All right. Let's do number 1 from the worksheet, and everybody has a little head start on the homework now, okay? So let's walk through how we do one of these problems again, okay? Where do I start one of these problems? The inside. So far, so good. So I'm going to say theta noisy out there. Oh, what are they thinking? They're just coming back from lunch or something? They should just shake it off here. All right. So again, we start with the inside, right? We're going to call the inside stuff theta. That allows us, if theta is cosecant inverse, then cosecant theta should just equal x, right? If I go back to sine, cosine, and tangent, what does cosecant theta mean? If I go back to our right triangle trigonometry, what is cosecant theta in terms of opposite, adjacent, and hypotenuse? What is cosecant theta in terms of opposite, adjacent, or hypotenuse? I remember cosecant is the reciprocal of sine, right? Sine is opposite over hypotenuse, so cosecant has to be hypotenuse over opposite. So I'm going to label my right triangle with an opposite side of 1 and a hypotenuse of x. I'm then going to use the Pythagorean theorem to find that other side. Notice that I didn't even bother writing the plus or minus because I know that I'm computing the side length of a right triangle, so there's no sense in writing the plus or minus when I square root both sides when I solve the Pythagorean theorem. How we feeling? So far, so good? Okay. Now we're going to do the outside part. So I'm going to do cosecant of theta, or I'm sorry, cosine of theta, which is adjacent over hypotenuse. If I go to my right triangle, the adjacent is square root of x squared minus 1, and the hypotenuse is x. And I'm done. How do you guys feel right now on what we've done so far? Is this okay? Fairly, like, haven't really done anything new. We're using the same set of ideas, right? We're just kind of doing a different kind of problem with them. Today, this is as far as I want to go with kind of these ideas. So we're going to work on worksheet 4 and also
That's terrible.
delta math.
Trying to kill it.
I am, slowly though. Oops, that's not what I want to do either. So here's the good news. There's only 2 problems that I'm asking you to do in the delta math. These, though, are different kinds of problems than we've done before. Let me do one of these. So I'm going to pretend to be a student here.
Be me and do one.
I can't pick a specific student. So these two are timed problems. So this asks quadrants of a trig functions.
It's timed.
Yep.
What?
Oh, like watching the video and then doing
Nope. So I'm going to hit start. Notice the counter's going. So I have to decide where sine is negative. Quadrants 3 and 4. Sine negative. Quadrants 3 and 4. Cosine negative 2 and 3. Cotangent positive 1 and 3. And you have to get a streak of 15 to count. So you may have to do this many times.
If you're wrong, you have to restart all over.
So I got it wrong. It stops. I got 5 out of 15, so I'd have to restart it again.
Oh my god!
Yes.
I'm not gonna.
Mr. Kool-Aid. Wait, how many tries do you get?
I think I set it up so you can do it as many times until you get it.
So if I guess enough time.
But
Yeah, you gotta guess.
Yeah, you gotta get 15 all right.
here's the thing. Let's think about what this is. 4 seconds per problem. All you have to do is decide where the thing is positive or negative at.
Okay.
Right? That's all we're asking. How are you doing that?
Guessing.
All silly turtles crawl. That's all you're using. Right? Write it down on your piece of paper in front of you. There's no calculation to do. Right? It's just all silly turtles crawl. Okay? Yes. The time goes back to 0 and it wipes your streak back to 0, and you should have to do it again. Okay. The other type of problem, let's look at what this is. Combine radian angles. Pi minus 5 pi over 3. 7 pi over 4 minus pi. Fraction, addition, and subtraction. That's what you're doing, what you're being asked to do here. So like, should be able to do these in our heads because guess what, you guys? You are real bad at these, right? Anything involving a fraction we have like kind of a meltdown about. But like, we should be able to do this kind of stuff. But as soon as you get one wrong, what happens? Streak ends, gotta start over.
Going through all of mine right now.
Which one? Are you looking at the old one? Yeah.
How do you guys feel on this? Right? The problems I'm asking you to do, these time problems, not complicated, right? They're essentially like all silly turtles crawl and adding fractions. But you guys have demonstrated that we're not real good at either of these two skills yet. And these are things that we should be able to handle, right? The all silly turtles crawl we need to be good at because it's a key piece of doing everything that we did in worksheets 1 and 2. And adding and subtracting fractions should have been something we got really good at a long time ago. We still seem like we're a little rusty on that, so we're going to have some more practice on it. Are these involving pies? Yeah. Should the pi matter? No. Okay. I'm going to stop talking now, and you guys can commence working on. If you haven't finished worksheets 1 and 2, you could do that. If you didn't do the asynchronous assignment 1 through 16, you could do that. If you're caught up on those two things, you could start worksheet 4 that we just assigned. Or if you prefer, you can start with the delta math. Yes. Okay. Everybody feel clear as to what you could be working on? Okay.